Okay, this is 10.4, the formative quiz on distributive property. There are only 8 questions, so this shouldn't take too long. The first question says the constant, and I actually didn't need to write on the left. I should have just wrote the constant is -2 in the equation 4 times x minus 2 equals 5. Now, the reason why I wrote this question is because most people see the constant as the part that's not attached to the variable. They see -2 there and they think the answer must be true. But in actuality, the answer is false. And here's why. If you have x minus 2 multiplied by 4, you really have 4 groups of x minus 2. So your constant in this equation is not -4, it's actually -8. So your constant is -8 because the actual equation is 4x minus 8 equals 5. But we don't see it until we expand using distributive property. The second question says, to model the equation 5 times x minus 2 equals 40, you would need to use 50 integer chips, both positive and negative, to start. Well, if I expand this, I would have 5x minus 10 equals 40. I would need 10 negative chips for this, and I would need 40 positive chips for that. So in total, I would need 50 integer chips. I would need 10 negatives and 40 positives, so the answer therefore is true. Question 3, you have stunned. Oh, that's on video. Okay. For the next question, we have 3x minus 1 equals -6. If you expand using distributive property, you get 3x minus 3 equals -6, because you would have 3 groups of x minus 1. So you'd have 3 x's and a minus 3. You would add 3 to both sides. You get 3x equals -3. And when you divide both sides by 3, x would equal -1. If I wanted to check my answer, I could actually take my x and erase it and go 3 times -1 take away 1. And 3 times, well, -1 take away 1 is actually -2. -1 take away 1 is -2. And 3 times -2 is -6. So the solution to my x variable is -1. In question 4, we have 10 equals 5 times x minus 4. So x minus 4 would look like this. And if I had 5 groups of it, I would have 5x, and I would minus 20. So we have 10 equals 5x minus 20. I would add 20 to both sides. And I'd have 5x equals 30. And all I would do to isolate is divide both sides by 5. And x would be 6, or 6 would be x. In question 5, we have -4 groups of x minus 1. Now the problem with this is I can't model it. I could model this, but once I have -4, I can't model -4 groups. So technically what we want to use here is just expansion using multiplication. So I have -4 times x, which is really just treated as a coefficient, -4x. And I have -4 times -1, which is +4. So when I expand that distributive property, I get -4x plus 4, not -4. I would subtract 4 from both sides to get rid of my constant. -4x equals -16. Divide both sides by -4. And x would equal a +4, because -16 divided by -4 is a +4. Question 6 asks us to model this. So if I have 2 groups of x plus 4, I would have 1 group of x plus 4, and I would have 2 groups of x plus 4. And that would be equal to 6. Oh, that's 7? Okay, this is question 7, though? All right, we'll go right to question 7, then I'll draw question 6. I might have a different one. So if I'm modeling this one, I really just want to see this as being 2x minus 8, or plus 8. Because really that's what it is. So once I model it, I'm just going to do what I would normally do and add -8 to both sides. Create my 0 pairs here. I'd be left with 2x equals -2. And therefore, if 2 x's have a -2 value, then each x must be -1. Equals 2/5. Oh, okay. Equals 2/5. Equals 2/5. Okay, so here's the question we missed. I put it in after this one. So It's minus 4? It is minus 4, isn't it? Okay, so, oh heavens. So this is minus. Okay. So what we have here is a complicated question. It's really enrichment. If you can't do it, don't worry about it. But we want to still apply the same principle. So instead of having x, I'm going to have a quarter of x, which many of us know a quarter of x can be represented that way. So a quarter times x is a quarter of x, or x over 4. And a quarter times negative 4, a quarter times 4 is really part of our fraction. It's going to be 1. And since this is a positive multiplied by a negative, it's going to be a minus 1. Okay? Equals 2/5. I'm then going to get rid of my constant by adding 1 to both sides. I'm going to get a quarter of x equals, you know what, I can either keep it as 1 2/5, or if I wanted to, I could make it 7/5. I'm going to keep it 7/5 because 1 plus 2/5 is 1 2/5, or 7/5. And then I'm going to multiply both sides by 4. That creates a 0 pair, and x will equal, I can't cross reduce, so it's 28 over 5, which is the same thing as 5 3/5, or as a decimal, 5.6. Both answers are correct. Question 7 said 10 students are going on a field trip. Each student takes $3 more than they are needed, plus in total they'll have $70. How much are they supposed to bring each? So the first thing I'm going to do is define my variable. And next is going to be the amount of money each student should bring, was supposed to bring. Supposed to bring. So if 10 students brought $3 more, and each student brought $3 more than they should have, so that would be x plus 3. And since 10 students brought it, I'm going to multiply that amount by 10. And altogether, all of that money is going to be $70. So now we have a distributive property question. If I expand, I would get 10x plus 30 equals 70. If I subtract 30 from both sides, 10x equals 40, and therefore x equals 4. So how much was each student supposed to bring? Therefore, each student was supposed to bring 4, and instead of bringing 4, they brought $7 each.